Welcome to this high-energy explainer. Today, we're looking at the sheer anatomy of velocity. We're going to completely reverse engineer an absolute marvel of biology to figure out exactly what makes the cheetah the undisputed ultimate speed king of the wild. Let's get into it.
Okay, let's dive right into this. I want you to imagine an animal that can accelerate faster than most modern sports cars you'd see on the road today. That's the baseline we're starting from. This isn't just an animal going for a run. We are talking about a living, breathing, biological missile. I mean, we're talking about launching from 0 to 100 kilometers per hour in an absolute heartbeat. The cheetah possesses this truly explosive acceleration, bringing a completely different league of momentum that literally leaves almost everything else completely in the dust. And at peak velocity, these guys can reach a staggering top speed of 100 to 120 kilometers per hour. But, this unbelievable speed doesn't just happen by magic. It's the result of perfect evolutionary design. Literally every single element of this animal has been fine-tuned for one specific purpose. Part 1. Lightweight frame built for speed. We're going to reverse engineer this incredible animal, starting right from its unique physical blueprint, which absolutely prioritizes extreme velocity over brute strength. Let's see how this builds. Unlike other big cats that are, bulky and super muscular, the cheetah has this incredibly narrow, streamlined body. And why does that matter? Well, a slim frame drastically reduces air resistance, allowing the cheetah to just cut right through the atmosphere for much faster, uninterrupted movement. As we continue this rapid anatomical breakdown, we gotta look at the skeletal structure. The cheetah has exceptionally light bones. By keeping the overall weight of its bodily chassis as low as possible, it requires significantly less energy to propel itself forward at those breakneck speeds. And completing this aerodynamic puzzle is the head. It's actually remarkably small compared to the rest of the body. This allows the cheetah to perfectly slice through the air, minimizing drag even further. It's built exactly like the nose cone of a bullet. Part 2, flexible spine, the spring. Now we transition over to the cheetah's mechanical core. We've looked at the static frame, but the spine is highly specialized for pure motion. It functions almost exactly like a high-tension spring. And this brilliantly illustrates how that biological spring actually works. As the cheetah runs, its spine rapidly stretches entirely out and then tightly contracts back together. This continuous, explosive stretching and snapping back massively increases the length of every single stride. It's phenomenal. Because of those incredibly long legs and that spring-loaded spine, the cheetah covers massive ground so quickly. In just a single second, it can take multiple huge steps, covering a distance that makes the strides of smaller animals look like tiny, slow little footfalls. Long legs literally equal massive, ground-eating strides. Moving on to part 3, claws and grip, the spikes. Let's shift our focus downward to the animal's connection with the ground. Because, hey, you can have all the speed in the world, but without traction, you just crash. Think of its paws as specialized high-performance tires or athletic cleats. Most cats have retractable claws that they hide away when walking, right? But cheetahs are completely different. Their claws are non-retractable, acting exactly like running spikes on a track shoe. They dig in and grip the earth tightly, giving the animal absolute, unbreakable control, even at extreme high velocities. Part 4, internal engine, heart and lungs. So we've got the lightweight frame and the gripping tires. Now let's dive inside the cheetah's body to look at the high-performance internal engine that actually fuels all this explosive forward motion. Now, what's really interesting about this is the sheer volume of oxygen delivery required. It's massive. At top speed, a cheetah needs huge amounts of oxygen. To handle this, it possesses uniquely large lungs and a highly powerful, oversized heart. These work together to instantly pump a huge surge of oxygen directly to the muscles, allowing for that explosive 0 to 100 acceleration we talked about earlier. But wait, with all this speed, how does it physically navigate without wiping out? Well, the cheetah's exceptionally long tail acts as a vital, highly responsive steering system. When the animal needs to make a sharp turn at over 100 kilometers per hour, the tail swings out to act as a counterbalance. It maintains perfect balance and totally prevents the cheetah from losing control and spinning out. Part 5. The price of speed. Limitations. Here's the twist in our deconstruction. In nature, every single evolutionary superpower comes with a significant biological cost, and the cheetah is absolutely no exception to this rule. So, the crucial point is time 30 seconds. Despite all of this incredible, fine-tuned engineering, the cheetah can only really maintain its top speed for about 20 to 30 seconds maximum. After that, extreme exhaustion and overheating set in hard. Because of this harsh limitation, every single chase in the wild is a desperate, exhausting race against time. When we contrast the cheetah directly with another big cat, like a leopard, the evolutionary trade-off is just stark. The leopard relies on heavy strength and endurance to survive. But the cheetah? It traded away that strength entirely. It is significantly faster, sure, but it's physically much weaker. Built for pure speed. To summarize everything we've uncovered in this explainer, every single part of this animal, from its small aerodynamic head down to its non-retractable claws, was designed for velocity over power. It lacks endurance, it lacks raw strength, but it traded all of that away to become the ultimate living speed machine. Which leads us to a fascinating final thought. In a wild where speed literally means the difference between life and death, what other absolute extremes has evolution engineered just to survive? I hope this sparks your curiosity to look a little closer at the amazing biological specializations all around us. Keep learning, and I'll catch you in the next explainer.